All right, so this is from 5.4 part 2 or day 2, and this was number 17, but we're going to go over this problem together. It's a great problem to talk about 5.4 in our textbook. So let S of t, usually known as the position, so I'm going to start annotating this right away, and this is the integral of f of x dx to be the position of a particle time in t seconds as the particle moves along the x-axis. So in these situations, when you have a particle, they're either moving up or down, or they're moving left or right, and because it's moving along the x-axis, it's going to move left and right. So our particle is either moving left or either moving right based off of plus or minus of the velocity. So the graph of f is shown below. The graph of f. So I'm going to label my graph f. Use the graph to answer the following questions. Sure. What is the particle's velocity at t is equal to 4? Justify your answer. So we need to find, this is, I said positive, but this is I meant position. This is the position function. The velocity is the derivative of the position velocity. So s prime of t is going to equal to the derivative of this integral. And the derivative of an integral undoes the integral, so we end up getting the function right back, f of t. So if we want f of 4, we're going to have to just read our graph. What is f of 4? 1, 2, 3, 4, and then 1, 2. And we say at t equals 4, the velocity s prime of t, which is equal to f of t, is equal to 2. And that is a justification why. It doesn't involve words. It involves one word, but it's mostly just your logic behind why you chose s of t. Okay, is the acceleration of the particle, acceleration, so we're going to talk about s double prime of t, of the particle t equals 4 positive or negative. So, like I said just now, the acceleration is going to be f prime of t, which is also to equal to s double prime of t. That's because that's the position. But let's go back to f prime of t. We have a graph of f. Therefore, if we want to find f prime of t, we have to find the slope. Not a big surprise that we are finding slope somewhere in this problem. So at t is equal to 4, is our slope positive or negative? And that's where you say acceleration, which is equal to f prime of t, is equal to a positive slope. Positive slope at t is equal to 4. So this is one way that I write it. I basically just write like what it is, like the acceleration, what they want in the question is equal to f prime of t, how it is it related to the graph. And then I answer the question, it is a positive slope, and then I give where is it the positive slope back to the question. So that's kind of the formula I use to justify my answer. Is the particle speeding up or slowing down at time is equal to 4? Okay, side note about speeding up or slowing down. So review. Speeding up, if we have the velocity and we have the acceleration, if they are the same sign, then they are speeding up. And by they, I mean the particle is speeding up. If the acceleration and the velocity are different signs, then the particle is slowing down. So you should write this down in your notes if you cannot remember that. If they are the same sign, they are speeding up. If they are different signs, they are slowing down. Okay, so now we need to see, we said that the velocity is positive at t is equal to 4 because we said the slope was positive. Oh, I'm sorry. The value is positive at t is equal to 4. It's equal to positive 2. Positive 2. And then the acceleration is also positive because we said that it was positive at t equals 4 because it's f prime of 4, the slope. So therefore, thus, the particle is speeding up. In your justification, if you write that the velocity is positive and the acceleration is positive, and you tell me when it is, then you can say conclude that the particle is speeding up. That's acceptable. Okay, so when does the particle pass the origin? Explain. Now, this is a graph of f, which is a graph of s prime of t. Let's go back to the original question. S of t is equal to the integral of f of x. This means that the position is the area under the curve of x. That's what this integral means. It means area under the curve. So when you read this, let's zoom in. S of t, the position, is the area under the curve f of x. With that in mind, let's go back to the other question. When does the particle pass to the origin? That is when S of t is 0. When your position is 0, you're at the origin. Okay. Position is the area under the curve. So let's take a look at our graph. The area under this curve, I don't know how much this is, but it's 6 by 3, half of 6 times 3. So it's negative. Now, let's zero out our area. Let's go 3 this way and 6 up here. Here is the same area, but it's positive. So these areas are going to cancel out. So this position, this means that the particle went left, and then at this time the particle went right. And then when it got to this time at 6, that's when it zeroed out its area for the velocity, which means it reached the origin. So when does the particle pass through the origin? S of t equals 0 at t is equal to 6. The area, how about the negative area? Between 0 and 3 is equal to the positive area from 3 to 6. So once the area is canceled out, it went left for this amount, this position. Whatever this area is, that's the position it was, it went left. And then it went right, the same amount, that position at 6. So it zeroed out the origin. Okay. There's going to be a part 2 of this video because I think I've talked long enough. So we're going to go over E, F, and G in part